You might have to install, replace, or upgrade internal computer components within a lab, so let's take a few minutes to look at how you work with internal components in the lab simulator. Notice that we have a button here called Motherboard. If we click on it, we see the motherboard within the system. Clicking on the Motherboard button is equivalent to removing the system case cover on a real computer and looking inside of it. There are three main areas within the computer. We have the power supply down here. The motherboard itself is in this area, and to the right, we have our drive bays. This is where we can install optical drives, hard disk drives, and so on. Let's take a look at each of these areas in a little more detail. We'll start with the power supply. Notice that on the back of the power supply, there's a bundle of wires, and on these wires are the various connectors that are used by the internal components within the computer. With the power supply selected, I can go down here to the Selected Components window, and it shows me all of the various connectors that are available on this power supply. For example, we have our main motherboard connector. We have our 4-pin and 8-pin CPU connectors, and we have our SATA connectors. If I wanted to install a component into this case, and that component required power from the power supply, I would look down here at the Selected Components window to look at each connector's thumbnail and figure out which one I should use. If you need more information about a particular connector, you can click on its Details link, and additional information will be displayed. For example, we can view the back, the front, and the top of the main motherboard connector. Underneath each connector, we see its status, whether it's connected to something or whether it's unconnected. This one is currently unconnected, but if it is connected to something, the status is shown right here. For example, we see that the CPU power connector is connected to the motherboard. Right now, the system won't power on without the main motherboard power connector. So, to connect it to the motherboard, we can click on it and drag it to the appropriate connector. Let it go, and now the connector's status has changed. It's connected to the motherboard as well as the CPU connector. In addition to the power supply area, we also have the motherboard area. You'll spend a lot of time in this area. This simulated motherboard has all the sockets that you will see on a real motherboard. It has a socket for the CPU, it has memory slots, it has storage connectors for our SATA drives, it has expansion slots. You'll use these slots to customize the motherboard according to the scenario's requirements. For example, over here on the shelf, I have a category called Memory Modules. One of the tasks in the scenario directs us to install a memory module in an open memory slot. To do this, I grab the memory module from the shelf, and then I drag it to the appropriate location on the motherboard. Notice that as I do this, a blue box appears that tells me that this is a possible location where I could connect the memory module. In addition to the memory slots, it also highlights a PCI slot and a PCIe slot. You can't install a memory module in a PCI or a PCIe slot. It's just telling me that it is an option. It's not the right option, but it's an option. Well, we don't want to do that. We want to connect it to the correct slot. I'm going to drag the memory module over a memory slot and then release the mouse, and the memory module is now installed in that slot. If you tried to connect this memory module to the wrong connector, for example, if I were to pull it out of the memory slot and try to drop it into my PCIe slot, an error is going to be generated, and it tells you, hey, you can't connect that device here. We can do the same thing with an expansion card. If we expand the network adapter category, we see that I have a network card on the shelf. To install it, I drag it over to the appropriate slot on the motherboard. This is a PCIe card, so I'll drop it on a PCIe slot. I'm going to hide this scenario so we have a little more room to work. I'm going to zoom in a little on the motherboard now. In addition to providing slots for memory expansion cards, there's also other active connectors on the motherboard, and you can see those connectors here. There are several SATA connectors down here that I can use to connect SATA devices to the system. Over here, we have front panel connectors that we can use to connect the power switch, the hard disk LED light, and so on to the motherboard. Don't worry about being able to decipher all of these connectors on the motherboard by the abbreviations you see printed on the motherboard itself, because there are many different areas on the motherboard. And because every motherboard is different, you're not expected to identify each of these different connectors and memorize its location. That would probably be impossible. In real life, the connectors on the motherboard vary depending on the motherboard manufacturer and the motherboard's model number. So to help you identify where the different connectors are on the motherboard, most motherboards come with documentation, and you can review the documentation to determine what connectors are where. Well, we can do the same thing here in this simulated environment. To read the documentation for the motherboard, click on the motherboard itself, as I've done here. And when I do, notice that the motherboard appears in the Selected Components window. To view the documentation for the board, click on the Details link. When I do, notice that the top view of the motherboard is displayed, and if I needed to, I could zoom in and out to see the various connectors on the motherboard. But more importantly, over here is the Specifications tab. If I click on the Specifications tab, an overview of the motherboard is displayed. If I scroll down here, a graphic is displayed here with the numbers that are used to identify each of the connectors on the motherboard. I'll scroll down a little farther, and here we have a legend that matches a description to each number. For example, notice that there's a number right here on this connector. If I scroll down the legend, I see that this is my CPU overvoltage jumper. In addition to a diagram identifying various parts of the motherboard, there's typically additional documentation on the Specifications tab that provides you with detailed information about various other aspects of the board itself, such as what kind of processor it supports, what kind of memory the board supports, and other configuration information that you'll need in order to work with this motherboard. For example, over here, it tells me this motherboard uses an LGA CPU socket. If I scroll down farther, there's more details about this socket. We also have a heading for system memory. Here it says that this motherboard comes with 4 DDR4 DIMM sockets. Down here, it tells us some recommended memory configurations. If we had just one DIMM that we want to install, it tells us where we can install it. If we want to configure it to operate in dual channel mode, then it tells us how the memory modules need to be installed. Let's close this window. Now be aware that in addition to the connectors on the power supply and the motherboard, there may be other connectors that are part of the system case itself. Let's zoom out just a little bit so we can see what we're doing. Let's select the case. Not the motherboard, but the actual case. Notice that it's outlined now. And down here in the Selected Components window, we see all the various connectors that are used to connect the system case to the motherboard. We have our power switch, we have the power LED light, we have a hard disk light, we have the speaker connector, and so on. The third area of the case that you need to be familiar with is the drive bay area, over here, located in the right of the system. The drive bay holds your DVD drives, your Blu-ray drives, hard disk drives, and so on. If I were to look at the front of the computer by clicking on Front, you would see that there is currently a DVD drive installed in the system. To get a better view of how this drive is installed in the system, I need to click the Drive Bays button. When I do, you see that I have an optical drive installed. Now, you'll note that while the optical drive is visible from the front view, the hard drive is not. You can only see it from the Drive Bays view. It's important to note that if you need to work with these drives in the system, for example, installing a drive in a particular bay, you have to do it from the Drive Bays view. It's not possible to move the drive to a different bay from the front view. If I go back to Drive Bays, I can click on the optical drive and I can move it to a different bay. And now, if I look at the front, we can see that the optical drive has been moved down. When you're working with Drive Bays, one of the key things that you need to be aware of is how to manage the cable connectors. Most likely, the scenario is going to require us to connect this optical drive to the motherboard with a data cable and the power supply with a power connector. Let's begin by talking about how to supply power to this optical drive. Over here, under Partial Connections, we have a picture of our power supply. If we click on the power supply, a list of all the connectors on the power supply are displayed. One of them is an unconnected SATA connector. All you have to do is drag it and drop it onto the power connector. The data cable will require a little more work. I'm going to click and drag the data cable over onto the SATA connector on the optical drive. Now one end is connected and the other is not. We'll need to switch back to the motherboard view and then drag the unconnected end over to the appropriate connector on the motherboard. And now we see that one end is connected to the drive and the other end is connected to the motherboard. That's it for this demonstration. In this demo, we talked about working with internal components. We reviewed the 3 main areas within the computer that you'll work with. We looked at the power supply area and the main board area, and then we ended this demonstration by looking at the drive bays.